Okay, this is a video about the naming and formulae, and we'll also include in properties of all of the different organic functional groups you need to know for level 2 chemistry. So, start with the basics. First things first is structural formula. A structural formula shows the entire arrangement of all of the atoms in space. Now we can either do it in full, like this one here, or we can do it in condensed, like this one here. Notice how every carbon atom in all of my examples has 4 different bonds attached to it. Okay, carbon must have 4 different bonds, or else it is not happy. It's not in a stable state. Alright, next we're going to start naming. So the first part about naming is knowing how many carbons you've got in your longest chain. Remember that carbons can bend around corners, if you like, and so if they do that, then you will get confused about what your longest chain is, so just take care there. You only need to know how to name up to 8 carbons, so these are really important. Okay, meth, eth, prop, but, pent, hex, hept, and oct. You will get better at them as time goes on. The other part to it is there is often other prefixes that come to the front of the name, so just take care with that. Okay, so you know how many carbons there are, you've got your meth, eth, prop, etc. prefix. The next step in naming is writing down which functional group an organic substance belongs to. Functional group is the reactive part of the molecule. So, for example, alkenes have a double bond, alkynes have a triple bond, alcohols have an OH. The only group without a functional group is the alkanes. They actually don't have any reactive part to their molecule, so just take care with that. Okay, so these are all the functional groups you have to be able to name. Alright, so you've got alkanes, alkenes, alkynes, alcohols, haloalkanes, amines, and carboxylic acids. You also need to know their properties, both chemical, how do they react, and physical. So if we start with alkanes, alkanes are really pretty much unreactive. They combust, they burn really well, but otherwise they're not very useful. Alkenes also burn really well, but they undergo 2 different types of chemical reaction, addition and oxidation. Alright, so they're a bit more reactive because of the double bonds. Alkynes, which should have a triple bond, see, but you can't see it, they are more reactive than alkenes, and they undergo the same reactions. Generally speaking, they don't really ask you about alkynes in the exam, so really focus your attention on alkenes. Alkanes, alkenes, and alkynes are all insoluble in water and have relatively low melting points and boiling points because they are non-polar molecules. Okay, alcohols up to butanol, so that's with 4 carbons, they are soluble in water because of the OH. After that, because there's more carbon atoms, then it becomes more and more non-polar, and so they tend to not be soluble. Alcohols undergo substitution reactions, alright, as do alkanes, which I should have mentioned earlier. Haloalkanes also undergo substitution reactions, and the 2 together, alcohols and haloalkanes, can have elimination reactions where they become alkenes. Haloalkanes are less soluble than alcohols because the chlorine or fluorine or bromine that's attached to the carbon is not as polar as an OH. Amines are soluble in water as well because NH2 is a very polar section, but only up to 4 carbons in the molecule, because once again, as you get more carbons in the chain, it becomes more and more non-polar in character. Amines you only really need to know are basic. Otherwise, you don't need to really know anything about them. Carboxylic acids, it's missing its bond to the OH there. They are characterized by a C double bond OH, and remember they are acidic. The H at the end attached to the O can be lost, and that means that it's an acid. Other than that, you don't really need to know anything about them. Okay, naming. Next step of naming is we number each carbon atom in the chain. Now, you've got to remember that you've got to have the lowest combination of numbers. So if you've got lots of different things attached to the carbons in the chains, in total, the total number added together should be low. Functional groups with oxygen in them come first in numbering, so carboxylic acids are always on carbon number 1. Alcohols should always get the lowest number. Then comes nitrogen-containing groups, so amines, and then comes everything else, all right? But functional groups, so that's a double bond or a triple bond, they get numbered first before a methyl or a propyl or an ethyl, so just a carbon chain. The exception to that, though, is if they also have an OH in them, which will get preference over a double bond. Okay, so if we have a look at some of these molecules here, they've been named and they've been drawn out in structural and condensed structural formulas. Okay, so the first one is but1ene. Notice how in the first diagram I've drawn it on the end, and in the second diagram I've drawn it on the beginning. It doesn't matter which way around I do it, it's still on carbon number 1. The second one is a triple bond here, and that's but1ine. Okay, then we've got an alcohol, a haloalkane, and an amine. There are two different ways to name an amine. Either put amino at the front or put the amine at the end of the name. Either way is fine. Notice how I've put an, so it's propan, in both cases of the name. That's because there's no C double bond C, which could possibly be present. So that's why we have to put in the an for alkane. In other words, all of the alkane bonds are present, so carbon is single bonded to other carbons. Finally, the last part of the name is any other branches, because they get the last possible numbers. They are the least important. All right. So, for example, this one here has got an alcohol and a methyl group attached to it. So we start off with the longest chain, in this case 4 carbons, 1, 2, 3, and 4. All right. And the functional group is an alcohol since there is an OH. Now, I can number it 1, 2, 3, 4 in one direction or in the other, and I'm going to number it in this direction because alcohol, OH, is preference with numbers, so it will be on carbon number 1. Hence, butan-1-ol. Notice how the 1-ol is in the name. You may see it online in the beginning of the name. That's not acceptable in NCEA. The branch then is still a methyl group, but as the carbon attached to the OH is carbon number 1, this must be on carbon number 3. Okay? Hopefully you found this really helpful, and let me know if you've got any more questions about naming, properties, and structural formulas.